Whatever the compound you take, it will having the same molecular formula, but it is physically as well as it is chemically different. Those compounds we call it as what? Isomers. Even though the compounds which is having same molecular formula, the carbon skeleton, it looks different. Hence it is known as what? Chain isomers. The carbon species which having the negative charge, we call it as what? Carbon anion. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we were dealing with the unit called Organic Chemistry, some basic principles and techniques. In this unit, we have learned about introductory part to the chemistry, and also we have learned that how the carbon is different from the other rest of the element by understanding the versatile nature, and also we have learned that the shapes of the organic compound, structural representation of organic compound, as well as the three-dimensional representation of organic compound. Today, let us go with the next topic of this unit by understanding with the isomerism and its type and fundamental concepts in organic chemistry, reaction mechanism. In that, most important one is homolytic cleavage, heterolytic cleavage, and types of attacking reagents also we are going to discuss in this session. Let us see what are isomers and how do we classify the isomers also. So as I already taught that the isomers is one of the versatile nature of the carbon. So it is necessary to understand how the isomers are formed and what are its types. Okay. The two or more compounds having same molecular formula but different physical and chemical properties are called as what? Isomers. Whatever the compound you take, it will having the same molecular formula but it is physically as well as it is chemically different. Those compounds we call it as what? Isomers. And these isomers are broadly classified into two types. One is structural isomerism and the second one is stereoisomerism. This structural isomerism again classified into four types. One is chain isomers, position isomers, functional isomers and metamerism. Whereas stereoisomers or stereoisomerism are broadly classified into two types. One is geometrical isomerism and another one is optical isomerism. Let us understand what is and structural isomers and how do they classified into four categories. When I am talking about structural isomerism, remember the compounds which are having same molecular formula but differs in their structures. Those isomers we call it as what? Structural isomers. For this, I can take an example of C4H10. So it is an butane. Okay, I'll write the structure now. So there are 4 carbon atom will be there and attached to the 10 hydrogen atom. This is a straight chain. And there is one more way of writing this. So this is the another way of representing C4H10, that is butane. Okay, where you can see that these two compounds are having same molecular formula but they are structurally different. This is called as what? Structural isomerism. As we have already understood that structural isomerisms are all of 4 types, correct? The first one is chain isomers or chain isomerism. When 2 or more compounds having same molecular formula but different carbon skeleton, they are referred as what? Chain isomerism. Suppose if you consider this compound which is having same molecular formula but there also differs in the chain of the carbon skeleton. They are known as what? Chain isomers, or the phenomenon which is known as what? Chain isomerism. Okay, you can see that the pentane which is having the 5 carbon atom. So you can see that here the pentane which I have written CH3, CH, CH2 and CH3, there is a one branching. So here is one more way. You can see the CH3C, CH3, CH3 and CH3. So in all this compound, it consists of 5 carbon atom, correct? So it consists of 5 carbon atom, but the skeleton of the chain will be different. This is a straight chain with a branching and it is completely branching, correct? So the name of this compound is isopentane and it is known as neopentane. And it is also in the IUPAC nomenclature, it is different. It is 2-methyl butane and it is 2,2-dimethyl propane. So this indicates that even though the compounds which is having same molecular formula, the carbon skeleton, it looks different. Hence it is known as what? Chain isomers. Next we have positional isomerism. The compounds which have the same structure of carbon chain but differs in a position of the double bond or the triple bond or with a functional group is called as positional isomers, and the phenomena which is called as what? Positional isomers. So you can write the compounds which are having a differs in the double bond, triple bond or with the functional group also. Here I have written, so CH3, CH2 and OH. So this is propan 1-ol. Why it is propan 1? It is containing 3 carbon atom. For the 3 carbon atom, it is prop, and since it is an alkane, we have to end with ANE, and you have to see that which secondary group is attached. Here the secondary group is OH, that is alcoholic functional group. So alcohol should be end with OL. So to the first carbon atom, the OH group is attached. So it is propan 1-ol. You can see that there is a one more naming CH3CH and CH3OH. So this is the first and this is the second and this is the third carbon atom. The second carbon atom has also got one of the functional group. So the name of this compound is propan 2-ol. So it is a propanol only. Both the compounds are propanol. It is an alcohol, correct? Having the 3 carbon atom. But the position of this functional group or the position of the double bond or the position of the triple bond maybe varies. Such isomers we call it as what? Positional isomerism. So here I have shown only with an alcohol. You can take the example which containing a double bond or triple bond or with a different functional group also. The compounds which have the same name like a butanol, propanol, like that. The position of the functional group will be different. So this is known as what? Positional isomerism. Next we have functional isomers. The compounds which have the same molecular formula but different functional group. They are called as what? Functional isomerism. You can say that we have propanone and we have propanol. So in the propanol you can see that ketone group is attached. So this is a ketone group and it consists of how many carbon atom? 3 carbon atom. For the 3 carbon atom we say it is prop. Since it is in ketone, we have to see the position where exactly the ketone group is attached to the second carbon atom, correct? So it is say as ketone, so it is propanone. So it should be end with O-N-E, propanone, okay? Or you can say propan 2-one also, or propan 2-one, okay? Next you can say that this is also a 3 carbon atom which is having aldehyde functional group. This is an aldehyde functional group. So how do you name it? This is 1, 2 and 3. So it is propan 1-Al because it is an aldehyde. So this shows that the compounds which having the same number of carbon atom, correct? So both are propane only. One it is propanone, one it is propanol. This shows that the function group, if it is there, such carbon atom, even though they have the same molecular formula, if the functional groups are different, we say it is functional isomerism. So for that, you should have a knowledge of functional group like aldehyde, ketone, carboxylic acid, ether, esters, all those things you must know that, okay? Next we have the fundamental concepts in organic chemistry, reaction mechanism. So in the organic chemistry, we know that when we are writing the reaction, we must have a reactant. That reactant must have what? The carbon-carbon linkage, and it must consist of carbon and hydrogen with other element also. And When this reactants is going to react with one more reactant, we call it as attacking reagent, which is going to form an intermediate complex. That intermediate complex later, it will decomposes and give rise to the respective product as well as with a byproduct. This mechanism that we can express in a different way. So generally we write it that organic molecule or the reactant molecule as a substrate, which is going to react with an attacking reagent to form an intermediate, and later this intermediate will be decomposed to form an product. Okay. So the sequential count of each step describing a details of electron movement, energetic during the bond cleavage and the bond formation, and the rate of transformation of the reactant into the product is referred as what? Reaction mechanism. Okay. So now you need to understand different kinds of how does the reactant will be taken up and what all will be the attacking reagent, that you must understand, and what will be the intermediate also. First I will go with the organic reactant or a substrate. So when the reactant is there, if it is going to react with an attacking reagent, it undergo the fission or the cleavage. This cleavage are of two types. One is homolytic cleavage and the one is heterolytic cleavage. Let us understand what is a homolytic cleavage and heterolytic cleavage in detail. Okay. Now I will go with the homolytic cleavage. If you see this example, I have considered an ethane. We know that this is a one methyl group, this is another methyl group, they are sharing one electron, correct? So what will happen in the homolytic cleavage? Homo means same, okay? Same kind of atoms if it is there on both the sides, What will happen? The shared pair of electrons during the cleavage, it will be equally distributed and results in a formation of free radical. So in the ethane you can see that the methyl group and another methyl group, they are sharing one electron. During the cleavage or during the fission, the free radicals or the methyl free radicals will be generated, and it is a neutral species which is having odd number of electron. Okay, they are called as what? Neutral species with the odd number of electron. This is how, if the cleavage takes place between the same kind of atom, we say it is homolytic cleavage. Let us go with the heterolytic cleavage now. Hetero means different. If a cleavage or the fission, if it takes place between the two different atoms, we say it is heterolytic cleavage. You can say that the methyl group as well as with the chlorine group are the two different atoms, they combine to form a molecule, correct? So the methyl group is going to share one electron, whereas the chlorine is going to share one electron. But this chlorine is more electronegative than the carbon, correct? So that is why a shared pair of electron will be more attracted towards the chlorine. Thereby, all the electrons will be shifted towards the chlorine only, so that the methyl group get the positive charge and the chlorine will get the negative charge. This way of getting a positive and a negative charge, the carbon, if it is gaining a positive charge, we call that as carbocation. If the carbon which is having a positive charge, we call it as what? Carbocation. So you can see that how does a carbocations will be formed here. The species which is having carbon atom possessing a positive charge, we call it as what? Carbocation. Remember the carbocation, which is one of the intermediates of heterolytic cleavage. Okay. So you can see that RCH, and this is one of the halogen, and imagine this is one of the alkyl group, and this is one of the most electronegative element. During the heterolytic cleavage, the bond has been shifted so that carbocations will be formed with the halogens which carries the negative charge. And coming into the stability order, the primary carbocation is least stable than the secondary. Secondary is least stable than the primary. Least stable than the tertiary. You can see that tertiary carbocation is more stable than the secondary, and secondary is more stable than the primary. Then what is primary, secondary and tertiary? You can see that the carbon to which other carbon atom which is attached, we say it is primary. The carbon to which other two carbon atom if it is attached, we say it is secondary. The carbon to which other three carbon atom if it is attached, we say it is tertiary. This is how the stability order of the carbocation which has been formed during the heterolytic cleavage can also be understood, and this is the one thing that you must know that for your competitive exams. We have one more intermediate, that is carbon anion. You can see that how does the carbocation, the order will be looks. So this is a primary carbon cation, this is a secondary, this is a tertiary. Okay, in all this way, the tertiary carbocation is more stable, and this is very, very important for your competitive exam. Now let us understand what is carbon anion. The carbon anions are also a carbon species which carries a negative charge. How does they get a negative charge? Let us understand with an example. Here I have an example of RCH2X. Here the halogen is a more electronegative than with the one of the alkyl group. In such cases, what will happen? Carbon atom which is having a more electropositive nature, which accept that electrons, thereby it gains a negative charge, and halogen atom will get the positive charge. The carbon species which having the negative charge, we call it as what? Carbon anion. You can take it with the example, here CH3 and CH2 minus. It is methyl carbon anion, and this is dimethyl carbon anion. You can take with one more example, that is CH3Cu. So this is more electropositive than the carbon, so that the shared pair of electrons will be completely moved towards the carbon only. Thereby the carbon gets a negative charge and copper will get the positive charge, and this will act as a carbon anion or carboanion. Okay. Next we have free radical. So in the heterolytic cleavage, which are the intermediates? One is carbocation and the one is carbon anion. Next thing is free radical. Remember, the free radicals are nothing but a neutral species which having an odd number of electrons, which has been formed from the homolytic cleavage. You can see that Cl, CH3 and C6H5. And the order of reactivity also you can understand that methyl free radical, ethyl free radical, isopropyl, as well as with the tertiary free radical. The tertiary free radicals which is more stable than the methyl free radical, and the order of reactivity will also goes in this order. Next we have attacking reagent. Attacking reagents are of two types. Okay, one is nucleophile and the one is electrophile. We all know that nucleophiles are nothing but nucleus loving species, and all the negative charge species which are called it as what? Nucleophile, and they are ready to donate the electron because they have an excess of electron. Whereas electrophiles are those compounds which are always loving towards the electron because of the deficiency. They are capable of accepting the electron. Okay, you can see that OH minus and Cn minus are the example for the nucleophile, whereas in the electrophile you can see that is an C double bond O keto and R3C and X. They are the examples for the attacking reagent. All positively charged substances or the species or the ions, we call it as what? Electrophile. You can take CH3 plus, even Br plus also. Okay, you can write the plenty of exam. Next one is metamerism. Let us see what is metamerism. It is due to the presence of different alkyl group on either sides of unfunctional group in a molecule. For example, C4H10O. So that can be written as C2H5O and C2H5. On another way, you can write that CH3O, C3H7. Now, if you count that, there are 4 carbon atom will be there, and there are 10 hydrogen with 1 oxygen. Similarly, for this also you can write C4H5 plus 5, it is 10, and this is also 1 oxygen. This shows that on either side you can show the different alkyl group, and it is not a functional group, hence I have written unfunctional group in a molecule. They are called as what? Metamerism. So hope you have understood what are structural isomerism and its 4 types. In the next class, we are going to discuss with the electron displacement reaction or the electron displacement effects in the organic compound. So hope you all understood with the session. I'll come back with the next topic. Till that, take care, be safe. Thank you.